Greetings! Welcome back to Algebra 2 Video Hour. We're going to do section 2.2, direct variation. Alright, let's talk about direct variation equations. It's y equals kx, or if you want to isolate the k and solve for it, it's y divided by x equals k. Now I'm thinking that k is very special because my name is Kendro. I don't know, Miss Johnson, how come they're not using a J?
I don't know. I'm not cool enough, apparently.
Well, if you've been teaching as long as me, then you get special privileges here. All right, some of the things you have to know about direct variation. Always passes through the 0, 0. When you draw the graph, 0, 0 is going to be one of your numbers. All right, also, you can think of y equals kx as a special form of y equals mx plus b. The k is a lot like the m. So you could think of it as special K. But I eat Cheerios. All right, the X is still your input, the Y is still your output. And the K, which I need to make a small correction here, is the constant of variation. That's how you remember the K. It's constant. The book got that wrong, I think, so I'm just going to make that correction.
All right, this is Miss Johnson. We're going to move on to our next examples here. First type of thing we're going to do is we're going to be given a chart that contains x and y values, and our job is to determine whether or not this is direct variation. If so, we have to find the k value. So remember Mrs. Kendro told us about that special formula to find our k. We're always going to take our y's and divide it by our x's. So I'm going to make a third column in our chart here, and I'm going to call it the k column, and we're going to run a little test. To do that, we go through and we're going to take all the y's and divide them by the x's. So the first one would be 2 over 1. That equals 2. And the next one, 6 over 3, also equals 2. And then the last one, 8 over 4, equals 2. It has to equal the same number every time, and that's why it's a constant of variation. Or maybe for Mrs. Kendra, we'll change that. Constant of variation. So that means my k value is 2. Yes, it is direct variation, and our k value is 2. Let's try another one. So I'm going to add my k column on the end. Divide all the y's by the x's. So 4 over 1 is our first one. That's 4. 8 over 3, that's just 8/3, and 11 over 4. These actually don't end up being constants. They're not equal to the same number, so it is not direct variation. And if it's not direct variation, you cannot find your k value. All right, I'll pass it off to Mrs. Kendro. She's going to continue on with the next type of problem.
One other little thing about direct variation is it makes a straight line, so if you're not getting the same change every time, that line's going to start curving a little bit. So that's another way if you're looking at a graph. Now, they're going to ask you, is it direct variation? And all you have to do is look at this little equation over here and try to get it to match. So if you notice, y is by itself, so I'm going to get y by itself over here. So I'm going to divide both sides by 3, and I get y equals 7/3 x. Now I put the x out to the side. You can put it either way, but this way separates it so you know exactly what k is. And so that's in the form y equals kx. So yes, it is direct variation. All right, the next one, we do the same thing. We want to get y by itself, so I'm going to divide everything by 3. I get y equals 14/3 x plus 7/3. Now, does that look like y equals kx? Kind of, but we have this extra little thing out here, and you can't have any extras. It's got to be what it is. So this is a no for direct variation. All right, the next part is proportions. I'm going to hand it back to Miss Johnson, and she'll take it away.
All right, you can use proportions not for any linear equation, but only for things that are direct variation. So when we move on, I think it's the next section, we start doing other linear things. You cannot use proportions unless it's direct variation or similar figures in geometry or something like that. So it tells us y varies directly with x. So as soon as they say this, they're telling you that it is direct variation, and therefore all of our k's are constant throughout the whole problem. Therefore all of the y's over the x's should equal the same number. They tell us that we know that y equals 9 when x equals negative 15, and they want us to find what y is when x equals 21. So we're going to set up a proportion to do that. All my y's divided by all my x's. And I'm just going to substitute. The ones that they have together first, they have 9 for the y value over negative 15. And then the second item they tell us we don't know the y, so we're just going to use that variable there, and then 21 goes on the bottom. Now to solve a proportion, we cross multiply. So we're going to have to do 9 times 21, 21, and then that's equal to multiplying the other two items together. That'll be minus 15y. And when we do that, we get 189. That's equal to negative 15y. The next step would be divide by negative 15 on both sides. And when we do that, we'll get a decimal. It ends up being negative 12.6. Okay, so that's the missing piece for y according to that proportion. Okay, our last type of problem is a word problem or an application. It says a salesman's commission varies directly with his sales, and that makes sense. The more you sell, the more money that person's going to make. For $1,000 in sales, his commission is $85. What is his commission for $2,300 in sales? I gave some hints to you over on the side there. It says identify the variables. Remember that it's all about direct variation here, so k equals y over x, or you can think of it as y equals k times x. We're going to find that constant k, but we need to know what do the y and the x represent. We always say that y varies with the x. So look at the words that they use in this problem. They say that the commission varies with the sales. Therefore, our commission is going to be y and our sales will be x. So let's write that down. X is going to be sales and y is our commission. Okay, so we identified the variables. That's the first thing we need to do. The next thing we need to do is find our k. So let's use that formula, k equals y over x. And let's pick some y's and some x's that we know. Remember, y is commission and x is sales. So if you look at the second sentence, it says that we do $1,000 in sales and the commission is $85. So our 85 is our y value because that's our commission, and that's going to be over 1,000. When we divide those out, our k value is 0.085. That's our k. Therefore, the equation for this whole salesman, any situation that he's in, looks like this. Okay? We can plug any amount in for our x value, and it would tell us what his commission is going to be. So the last sentence they ask, what is his commission for $2,300 in sales? So we'll take 2,300 and plug it in there. Oops. Just multiply those two numbers together, and we get $195.50. That's how much he makes. So we really were asked to do two things. We had to find that total number, but we also found the k, or the formula that works for the situation. And I think that'll do it for our direct variation lesson here. What do you think, Mrs. Kendrow?
I'm thinking we directly did it fastly, and I've never worked for commission, have you?
I don't think so.
I don't know who that is, working for commission.
No.
Well, anyway, it's been real. We'll see you guys in class.